Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about Lunar Colony Foundation. So let's dive deep into it. Now, before we go into the moon, we need wings. That's the first thing. Thankfully, we have completed the sight stage, meaning have we been there? Have we seen it? Yes, we got it. We got the map, very high resolution map, thanks to no atmosphere. It's surprisingly sharp. We got it. Like we got it. ISRO even helped in that. Everybody, like we got it. The data is sorted. So we have more than enough data to start the second phase. But what do we need? We need big yeffing rockets, very big powerful rocket. Like we really need BFRs. Now earlier in humanity, people were putting their hope into this puppy. This puppy is supposed to be launched in 2010. Now the design is actually good for 2010 era. Not anymore. Like how badly it is outdated. Even NASA wants to cancel it, but they cannot simply because SLS stands for Senate Launch System. There is a lot of lobbying going around on the senators. Senators are like making it alive. But I'm reasonably sure it can only fly for 1 or 2 times because the cost per launch is so stupidly high that even NASA would be at some point NASA will just give them the bill. It's like, can you pay this? So this was a hope, a good try, but horrible consequences. So that's a bye-bye. Thankfully, there is private player that is trying to develop their own system and it has some serious potential. Now, will it work? Most likely, yes. Now, will it work quickly? Hell no. Do expect some years. So, but rocket part is sorted, and be mindful during this time, there's a good chance we are also working on some other players that are making medium-sized rocket, but again, reusable. And if they can achieve medium-sized rocket with human rating, it could allow us to bypass the safety hassle of this puppy, meaning you launch this, but send humans using different rocket like Falcon 9 or maybe New Glenn or whatever have you. So, there are some options here. So, rocket part is almost sorted, and we can see it like where we're gonna be in few years' time. So, that part is sorted. That's awesome. Now, orbital refueling is something that we must solve. Can we launch at this point in time, launch this puppy and send something to the moon? Absolutely. Should we do that? Not really. I was like, why? Well, here's the deal. That's literally how we did Apollo missions. Apollo missions were way too bare bones. If we really want to do things on moon, let that be very clear. Do things on moon, we need tonnage. We need some serious tonnage. It's one thing fine and dandy to send one truck, but if you really need to move material, you use a shipping container. Same thing. We need some serious tonnage to go there. The only way to get that tonnage is in space refueling. Can we do that? This is currently going on. This is a trial that is going in space for satellite refueling. But again, proof of concept is very important. So this is under construction right now on a conceptual level. How the heck we're gonna do this? This will be designed for refueling second stage with little bit of propellant. Let's see how that works, but it must be there. For our wings to truly unfold and truly go, we have to unsolve that, basically remove that blockage. Then we come to the final aspect. This is why Apollo missions kind of faded out, is that we need stable long-term self-funding. Self-funding is the critical aspect, meaning would governments invest some money? Absolutely. Would government invest in long-term? Well, define long-term. Like 5-10 years, I can see that. 15 years, okay, pushing it, but 30-40 years, it's not army, it's not gonna get it. So you have to design something that is like uses government as a springboard and then goes into their own direction. Stable long-term self-funding. Are there options for us? I have narrowed down 3 options that will work on day one. First option, archiving, meaning storing things on moon. It does not require a pressurized cabin. It just requires something that is shaded, and ideally you land it directly into some shadow crater, or you can just cover it with regolith, and it does not need to be pressurized. You just put stuff there and forget about it. Be it DNA, be it books, as in like a books micro etched into nickel. If it's digital data, there are one technology that I have seen that is reliable in long term, that is 5D glass storage. I have made videos about all of those. That's one way of archiving data, and another way would be storing DNA samples. That can also be done. Very low energy or almost no energy on moon. If you design it right, it would be no energy. So that can be done, archiving right now, and humanity as a whole spends a lot in archiving. Then we have tourism. This puppy has like money like there is no tomorrow. So we really need to milk this. And then we come to observation. Observation of two fronts. Front number one, Earth itself. Front number two, basically deep space, shadow of the moon. Because in that area is completely radio silent. So we can do things. So these 3 things combined can easily create what we call self-sustaining economy, meaning once we have the springboard, once we actually get there and start these things, it can pay us enough where it's like, okay, we get it. Like how space industry started as in like satellite only government experiment, then they're like, oh, TV satellites. companies are like, hey, what if we launch our own satellite? And then brick by brick, day by day, now majority of the satellites are private satellites. So that's how you develop it long term. So this is the wings part of it. So let's give a time frame from 2030 to 2040. These are optimistic timelines. Idea is that we at the end of 2040 we will reach a point where we'll have permanent few human crews presence. What does that mean? That simply means exactly like how we have ISS. There is always somebody rotating. Same thing would be there on the moon. Let that be clear. On the moon, as in like even if we have deep space gateway, people would be going in and out from lunar surface so regularly that there will always be some presence. It could even have multiple countries working on it. So permanent presence, exactly like how we have a permanent space presence since construction of ISS, same thing. And in this phase, like during 30 to 40, we're going to focus on construction and assembly tools. Basically, how the heck we're going to do it? Because be mindful, Apollo, like this was a folded, mess, so to say. You should look at the video, how the heck they folded it. It is very interesting. That's good, but we really need to do better. So for that reason, we have to figure out how to do construction and assembly. Exactly how we did with ISS. ISS was not launched as a complete unit. It was built in space. Same thing, built on moon. So that's how we're going to figure that part out. And primary focus in this time zone would be logistics and mobility. How the heck you move around? How the heck you get supplies delivered? All these things have to be sorted. Like where do you launch a rocket from? Where do you land the rocket on the moon? All these thing data has to be sorted during this phase. This would be the early stage, almost start like a Apollo, but it will grow very quickly because we have to sort all this puppy out. This time rovers have to be tested. New rovers. This rover was like 1 horsepower. So okay, a good start, but we need better. And not to mention this time we're gonna be damn sure that we have much exponentially bigger dust cover. But you get the point. Like we have to do some things, improve this puppy and have some better tools, maybe even a pressurized tool. So logistics, mobility, and spacesuit. This spacesuit era that we had, it was like hope for the best era, and that's not good enough. We need something that is like actually good. And how the heck you're going to test it? Testing it in a lab is just lab data. So you really need to use it in the moon. So this will be the first phase. Figuring out construction, figuring out assembly, figuring out logistics, mobility, all of this, like how the heck we're going to do this, will be sorted in this period. That is 2030 to 2040, optimistically. Then we come to 2040 to 2050. Now this is second phase. Now in second phase, basically we start the money phase, because if things are going well and we really start to put human boots on the lunar surface around 2030, people will be bored by 2040. It will be boring thing. People will like, who cares? So we really need to make sure that money part starts to come directly after that, before government pulls the plug. So what is the best way of doing that? Well, tourism. You can see that Dear Moon right now, like this billionaire wrote a blank check. It's like not very blank check. I do expect it to be around 4 to 5 billion that he has spent. But you get the point. Like there is more than enough billionaires and they have more than enough money in their pocket that tourism is like, we good, we go. And once you have the pipeline sorted, there's more than enough millionaires that is like it's a completely continuously self-sustaining system. So we good. So tourism, but it does require something serious. It requires hotels. How the heck you can actually keep people there? And then logistics. Logistics will be sorted in that last one. And because of the assembly stage, we will figure out how to heck we have assembly of hotel sections. So that's one, tourism. That's like big money. Then we come to basically observation side of it, meaning using lunar, basically real estate as a observation post. This is an example that NASA is right now working on. It is from MIT, and the idea is using basically far side of the moon. What does far side mean? Far side simply means side that is facing away from Earth. Earth is tidally, basically moon is tidally locked to Earth. So from our vantage point of view, we only see one side. So if you go on the dark side of it, there is benefit that in dark side, if you put a radio dish there, that dish will be completely shielded from Earth's emission. Earth has an emission, like a spherical emission. That emission would be shadowed because of the moon. So this is the best place to put a radio telescope, and you can observe amazing things. Now, do we pay for these things? Yes, on Earth we pay for these things. So doing this on moon allows some significant enough advantage where construction cost, maintenance cost, and be mindful, this was designed as a robotic system. It's just like one lander that lands in the center and just like spring launches it. Imagine doing that when you have somebody who can go there and look into it. Like, that allows you to, this will be, let's say, prototype 1, then you can launch prototype 2, or let's say something else did not work, you may try to actually fix it, repair it, or like, hey, this did not work. And we did that. We have done this sort of thing in basically when ISS was unfolding its solar panel, one of them got stuck. The people actually went into spacewalk and fixed it. So same thing can happen here. So of course, hope it does not require that, but it would be awesome that we have people there and we are using it observation. Like a radio telescope is the easiest. Optical telescopes can also be done. Be mindful, we have a lot of option there. Like we good. Like lunar surface can be used as a very good observation post for both reasons. If you want to do atmospheric study, having giant telescopes looking directly at Earth, and you have the luxury of looking at the whole Earth, you can study a lot. And it will have some pros and cons compared to geostationary orbit, but it has its own advantages. For that reason, people will like, shut up, take money. So this is right now going on. And then we have long-term lunar archiving. So at this point, you can start offering archiving service. All you have to do to physically do it is basically find a location which is in shadow, find a way to access that location, and then just put containers there. That's it. Container does not even need to be airtight. You can literally have an open frame container which just have a basic door so dust does not go too much in and out. But like, and of course you will have copies of that. So you just in spacesuit, you go there, you put briefcase there, and don't worry about it. May have a clock circuit to figure out who is putting what when. But it can be super simple. It does not require pressurization, does not require temperature equilibrium. So it can be done. Put it right now. So start with basic seed banks, then upgrade to data banks, then upgrade to serious data banks. Brick by brick, day by day, it can start earning. And this is very critical. We must make sure that companies are going to the moon on their own, not requiring government funding. Government funding should be helpful. It's like, hey, help, awesome. But it should not be necessary. Then we come to the final phase 3 of 2050 to 2060. Now, at this phase, we'll start what we classify as in situ utilization. So far, it would be phase 1 and phase 2 would be more or less relying solely on Earth. Like, can we extract oxygen from lunar surface? Unless you have a lot of power? No. Can we extract water from lunar surface? Yes. Is there enough of it? No. So this is one of those things. So only at this phase, once we have figured out 1 and 2, and once we have money, then we can start in situ utilization. Now, this puppy is the most extensive part because it is going to consume a lot of money, it's going to consume a lot of energy. So thankfully, there is one good thing, is that moon has more than enough oxygen, meaning regular QC, those are oxides. So we do not have to worry about oxygen. Like if you have energy, oxygen is like, take it and leave it. Don't even worry about it. It's like, you be good, bro. Unfortunately, it does not have enough O2, basically hydrogen. So we do not have H2O. You do not have enough water. Like, wouldn't we like, didn't we just find water? Here still, we humans consume water so quickly in such a large volume, specifically with industries, which you will need at in situ utilization, that yeah, we're gonna run out of water very quickly. Now, is there enough to get us started? Absolutely. Is there enough to go to expanse level? No. So how the heck we go to expanse level? For that reason, we'll start with Earth supply, then we'll start with lunar extraction, then we go to basically deep space extraction. Like what the hell? Yeah, basically go to asteroid belt and take a icy body and just dump it into moon. And that's how they did it in this basically science fiction show. It kind of makes sense. You have icy bodies. Of course, it will be very slow processes and take 10-20 years kind of slow, but it will allow you to have more than enough input. Now, there is more than enough minerals also on lunar surface. Like, we do not have to worry about materials. We good. Oxygen, we good. Materials, we good. Hydrogen is the only missing link. And not to mention, when I'm saying missing link, it's not like, oh, there is nothing there. It's just like, if we really start to use hydrogen for basically our rocket fuels, we're gonna run out quite quickly. We're gonna be feel like, what happened to the sea? Oh, it went poof. Same thing. So we really need to import in long-term water, basically. Thankfully, because of our development in ISS, we figured out that we can do very high efficiency water recycling, almost 90% efficiency, or more than that is achievable today. So what does that mean? That simply means if we are building lunar settlement where you have hundreds of people at that point in time, or even thousands of people, at that point in time, even the water consumption would be huge. We will not need new water that much. Like on Earth, we consume a lot of new fresh water. That's why all freshwater reservoirs are depleting. That won't be as quick in moon simply because we will recycle everything. And since it's an airtight environment, it's actually doable. And we have already learned from ISS, it can be done. So that should reduce how many basically ice asteroids we have to crash onto the moon. The numbers would be low. So moon can become, at this phase, moon will become second base, meaning we'll have enough people there. We'll like exactly like how you see in Ad Astra. But this looked so silly to me. It's like, who the heck? Like on moon, they have like this advanced system, everything's fine, everything is awesome. And then they have like a freaking escalator. Who the fuck put an escalator there? Like what? Like that escalator made it like, like what the hell? Nobody's gonna put escalator on the moon. It's like, that was so silly. That was the silliest thing I've seen. Like so far, everything detailed, scientific. At that point, it's like escalator. It's like they really wanted to make sure that you think like it's shot in an airport. I'm like, that's not a good thing. And then we can use basically spin launch now. Don't I say spin launch is useless? Yes, on Earth. On moon, you have two advantages. First, low gravity, meaning how big you can build it, that spinning arm. It becomes, well, you can make it much bigger because it does not have to fight against gravity. Second, because there is no atmosphere, this puppy does not require complicated vacuum seals and vacuum pumps. So you can launch a lot of stuff into lunar orbit, which is much lower energy, for very little less. Heck, you can just launch it and circularize the orbit using pressurized oxygen. You want to have, like, we have more than enough oxygen gas here, so we're not going to run out, at least for a few thousand years. So that's how you start. You launch a lot of it without too much hassle. So this is the final phase, and all three will be keep working basically parallelly. Basically, tool development will keep going on exactly like how we do it today. Also, archiving will keep growing. We'll start digging downwards and putting bigger and bigger vaults for more longer and longer data storage. Things will keep progressing, and this stage will be like, okay, Earth has finally second hold on this point, because this phase should be big enough, rich enough, where lunar population should be able to grow on its own and then feed itself. Of course, it will still rely a very weak link with Earth, but that link would be more of add-on link rather than compulsory link. At least for short duration, let that be very clear. They will still need a lot of money, a lot of stuff coming, and tourists coming in and out from Earth, but they got it. Like the foundation would have been laid at that point. Now we come to the most critical aspect of it. Why the heck bother with that? Because again, I know more than enough people that are like, why do this? We have problem here, and then it's like, here's the deal. Right now, what is the most dangerous thing to humanity at this moment in time? People say climate change. Hell no, that's chump change. That's easy for humanity to solve. Now, like, why the heck we have not solved it? Well, we are solving it. We destroyed that puppy for 200 years. It's gonna take at least 100 years to solve it. So we are working on it. It's gonna take time because again, we messed up in a long time. It's gonna take time to fix it, but we got this. I have seen more than enough proof that like we are going in the right direction. Sooner or later, we're gonna solve it. That's good. However, I'm not hopeful about that, because the biggest danger that I see on all of the planet, as in like India, USA, China, that accounts for around 3 billion plus people, is that we have lacked hope. Like humanity as a whole, as a collective, starting to lose hope. Like people don't see far through the horizon. We don't see, like we're just like blind. Like right now we are in a position where it's like future does not exist for us. Like blank. Like what is tomorrow? I don't know. Blank, gone, nothing is there. And that is very scary. Simply because if you are stuck, then it creates a feedback loop. That is like, if you're stuck, you cannot even imagine. Like nobody nowadays, no children even imagine for big things. They are imagining for something so poor. They're like, I want to be rich. Like there was a saying that, again, it took me time to understand. I'm 30 years old now, so I'm starting to understand it. It's like, some people are so poor, all they have is money. And I did not understood it in early days, but now I'm like, I get it now. So we are stuck there, where our imagination is so limited. It's like all people can think about, all children can think about is like money. It's like you will be stuck permanently if you keep thinking that way. And future will not be better off. Like we do not have a hope where it's like, let's say 2020s is okay, 2040s would be awesome, 2080 would be ultra awesome. We don't think that way anymore. Like back, this was a common sense in every country. That's why every country fought for their independence. That's the whole point. It's like tomorrow would be better than today. And we no longer have that. And the worst case scenario, it's a self-fulfilling prophecy. If we stop dreaming, we stop doing. Basically, if every child only thinks about how I'm going to be an influencer, how I'm going to be a rich person, all of them is going to do is like go into investment. Now, here's the deal. Investment is good and all. It works only if you have a company base that is actually doing it. If everybody instead like looks at Instagram and says like, you know what, investors have the real power, I'm going to be investor rather than CEO. It's like at the end they will find out, hey, we don't have any company to invest in. Nobody's dreaming. So that's why we really need dreams. Like if you ever wonder like what defines whether a country can grow and or survive, thrive very quickly, yeah, dreams. Trust me, it does matter. Like, here's the deal. Everybody hates USA, okay? Everybody. Okay, no problem. But here's the deal. How the heck USA gets so much things done? There's one thing no country with a good mind will ever say about USA. It's like they have confidence. Confidence about what? That's the whole point. They dream it and then they build it. Good, bad, better, worse, whatever have you. You have 10,000 problem, no problem. Like, I got 99 problem, balls into one of them. That's the whole point. We need to dream big. As a humanity, as a complete whole, we need to dream big. We cannot be just like, oh, I just want to have food. It's like, dude, we crossed that. We crossed that threshold long ago. We good. So we must break it and start dreaming big. Imagine, like, this was the starting sequence of Expanse TV show, a good TV show. The show, like, moon is there and then like whole colonies are spread up on the moon. It was a bit too extreme, but like I like that design. It's like, like, imagine that's happening. Imagine that it's 2050 and you can look up and randomly just spot, oh, a rocket is doing landing there. So many rockets are doing that. Of course, so many means like, let's say 5 or 6 a month, let's just say. You can see that, like, that from Earth, will like, oh, I can see it. And children looking that through the telescope, that so much wisdom would be there, so much hope, faith. It's like, oh, there is something actually up there. Can you imagine, like, looking up, upward mobility? That's what we talk about. Imagine actual upward mobility. Like, it would be necessary. Like, the whole country enjoyed this system. This whole country enjoyed. We just landed a tiny robot with 6 wheels. And everybody enjoyed it. Imagine what will happen if we see people doing that. Like, that's important. Like, significantly more. We really need to show people that future can be better than what it is today. That's the whole point of humanity. Will we have problem in future? Absolutely. We're supposed to have problem. We're supposed to create a new energy system. Then we're supposed to worry about how the heck that energy system messed up. Then the cycle repeats again and again. We keep moving forward. That's the whole point. So that's why we really need to dream big. And then we can go to Mars. Once we have moon, once moon is sorted, Mars of course will do that in parallel also, but moon would be the first base. Once you have that first base, Mars will give you, like, we got this. And then hopefully we may not even need to really expand Mars too much, because at that time we have figured out that, hey, we can actually build space habitat. If we can really start to mine moon, we should be able to do that quite easily. So this was my presentation on basically Lunar Foundation. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.